Let's discuss a question on thermodynamics. A cylindrical storage tank having an internal volume which contains methane at a given temperature and pressure. And now what he says is that if the tank outlet valve is opened for until the pressure is half, then the mass of the gas which escapes from the tank, assuming that the tank temperature remains constant. Okay, so we assume that the methane behaves an ideal gas. This behaves as an ideal gas. Okay, and so we use the equation PV is equal to mRT, where R is your characteristic gas constant. So how do you find out R? You find out R by universal gas constant by the molecular weight of the gas. So universal gas constant is 8.314 kilojoules per kg Kelvin, and kilojoule per mole Kelvin, kilojoule per mole whereas the molecular weight of the methane is 16. So this we get a value of 519.644. There's a point here, and this is in joules, it's not in kilojoules, remember that, by kg Kelvin. So this is joules per kg Kelvin, 519. Okay, so now what is given is initially the pressure is P, the volume is V, and mass is mRT. Okay, now the pressure is reduced to half, the volume, the remaining gas will occupy the same volume, mass will be obviously different because something would have gone out, R is again the gas constant which remains same, and the temperature is remains same. So obviously if you divide these two equations, so m dash will be m by 2, there's nothing else, m dash is m by 2. So the mass of the gas that has escaped is half of basically the mass that was there at the start. Okay, or the mass that remains is half of the mass that was there at the start, so half of the mass has gone out. So how do you find out m first? Because the answer is m by 2, but how do you find out m first? The m can be found out by using this equation. So m is Pb by RT, where the pressure is given as 137 bar into into 10 power 5 137 into 10 power 5, whereas volume is given as 0.465 and R is given as 519.644 into temperature is 20, that is nothing but 293. Okay, so this comes out to be 41.84 kg, and the mass that has escaped is m dash minus m by 2, which is nothing but m by 2, that is 41.84 by 2, which is nothing but 20.92 kg. So 20.92, let's look at the options. Well, 20.972, so option is A. Thank you.